We have wait for minutes. Minutes. Yeah, yeah. Wait. Students are joining. Mm, yes. There is. We have to wait for. My voice is audible. Yes. I think we have wait for more 1 minute. Uh, I think some student facing the network issue as well. Uh, yeah, I think there is some voice issue. Okay, I think there is 5 minute over. I think it's good to start. Yeah, so we can right now start our presentation. Yeah, okay, okay. So uh, the students in future they can be given chance to in our class. So today we have discussed about the wave particle duality. Already we have discussed introduction. Okay, how that particle we have in dual way, right? By means of studying the de Broglie hypothesis for matter waves, right? This one in previous case we have studied Louis de Broglie suggested that matter considered to be made up of discrete particles, okay, uh, such as atoms and molecules, may have wave under a proper condition, okay, and this proper condition is specified by de Broglie, and that it acts as a wave is called as de Broglie matter waves, okay. It's called as de Broglie's matter waves. Okay, that's it. So how we can already I have explained, and today also I will repeat here the de Broglie hypothesis for matter waves. A matter is considered to be made up of discrete particles such as atoms and molecules, and it behave like a wave under certain conditions, and that is called as matter waves. Okay. If we can say the it if you are to consider a moving particle, then its wave properties associated with can be summarized, can be written as lambda equal to h by p. That's it. Okay. uh, I will here take uh, here. Oh, here is that pointer. Okay, here is pen. Okay, I want to check that one. Okay, it's good. So lambda equal to h by p, this one. Okay. So what happen if I write lambda equal to h by mv, where mv is the what? P equal to m cross v. P is the what? Momentum of the particle when it is in moving condition. That's it. Okay. If for the relativistic mass m equal to m0 divided by square root of 1 minus v square divided by c square. All these factors already we have discussed in detail in previous lecture. So today we have to learn about what is the, just a moment. Uh, I want to check how many students right now. Only two, three students. Okay, students are joining. Okay, but taking much more time to join. Okay, because already we have uh, only, yeah, we have only 40 minutes. Okay, in that 40 minutes we have to arrange, we have to formalize our all lecture related to our syllabus. So today we have discussed about uh, what is the de Broglie wavelength in terms of energy and, yes, temperature, how we can define it. Okay. So for this case, de Broglie wavelength E equal to, as you know that E equal to, right, h nu equal to sc divided by lambda. Okay. How that one is? By using the Planck's theory of radiation, the energy of photon, all right, the energy of photon can be written as, okay. So just I will erase this one. Is this erasing? No. Okay, no problem. I will try to erase it. No. Okay. There is no issue. I think there is. Okay. So what happened for photon? If using the Planck's quantum theory of radiation, the energy of photon E equal to, we can write E equal to h nu, which is equal to Planck's constant into velocity of light c divided by wavelength lambda. That's it. This make the equation second. Okay. So for equation first, which is equation first? Lambda equal to h by mv. What? Lambda equal to h by mv. That one is the equation first. Okay. Okay. What is it? Lambda equal to h by mv. That one is the p. Make this equation 1. Okay. That is equation 1. Okay. That's it. And for another one, here this one is equation 1. Okay. Equation 2, if I want to calculate the energy of photon, then what happen? Yes, yes, what happen? I will write the energy equal to Planck's constant into nu, which is equal to sc divided by lambda, Planck's constant into velocity of light divided by wavelength. Okay, so sc divided by lambda. So nu is the what? Frequency, right? Nu is the frequency of oscillator. Okay. And c is the what? Velocity of light in air medium. That is 3 into 10 raised to 8 meter per second. Okay. That is the velocity of light in vacuum. And lambda is what? Wavelength, as you know. If I want to calculate wavelength, wavelength equal to what? Just we have to take instead of energy, we have to here instead of wavelength in equation 2, we have to energy. Therefore, what is it? Make this equation third. Okay. S divided by E. This one. That's it. Okay. This one. Lambda equal to Hc Planck's constant into C divided by E. That's it. So what happen if I take the if I consider the another instead of energy, I will write here very simple way, right? How that one is? After that, equation first is what? Wavelength equal to, yes, here I will take the pen. Yes, is there any problem? Anyone can have issue with voice? My voice is audible to everyone? I think so. Okay. Okay. So what happen if a particle of mass m is converted into energy? Okay, converted into energy. The equivalent energy is given by Einstein mass energy equation. So how I will express it? E equal to mc square. How I will express it? E equal to mc square. So how the equation 3 can be rewritten as? How I will write the equation? Uh, Third, this one. Third equation is which one? Lambda equal to Sc divided by E. Instead of this E, we have to put mc square. Okay. Here, lambda equal to Sc divided by mc square. Here, mc square. So h divided by mc. There, this square cancel, and here c cancel. Here h left. Okay, and here mc left. Okay. So, but we know that mc equal to p, right? Momentum, momentum with this associated with this quantum, then lambda equal to what? mc equal to p, then h by p. Equation 5, perfect. Equation 4, equation 3, equation 2, equation 1. Okay. 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 How many? Yeah. So for I want to check this one. Okay. Okay, right now it's okay. This one is some hindrances. So you can understand equation first, lambda equal to Sc divided by m, equation 1. Equation 2, if I want to write the energy of photon equal to Sc, right? Yes, E equal to H into nu, which is equal to Sc divided by lambda, equation 2. Then where nu frequency, c velocity of light in vacuum, lambda wavelength. After that, I want to write wavelength equal to Sc divided by E. Just instead of this one, inverse this term, right? Replace. After that, equation 3, I want to consider it as a Einstein mass energy relation, E equal to mc square. Then put this E value, right? This E value equal to mc square. So put this value in equation 3 and rewrite. So Sc divided by mc square instead of this E mc square, which is equal to If I cancel this c and here c square, h divided by mc. That's okay. So, but you know that what p equal to mc momentum. All right, the momentum associated with quantum. So I want to write this lambda equal to what, h divided by p. Rewrite this one equation, and you got the equation 5. That's it. Okay. So after that, if de Broglie postulated that it is true for energy packets, which we call as quantum, or photon, is also true for the material particle. Okay. Then, thus for particle of mass m moving with velocity v, okay, moving with velocity v, then how I will write it? Then for particle, if I take that particle is moving at that time, its velocity I will consider, right? Okay, that velocity p equal to what? Mass of the moving particle into whatever he acquired the velocity, that one is v, right? So p equal to mv. So write this lambda equal to h divided by mv, which is equal to h divided by p. That's it. Okay, and lambda equal to what? H by p. Okay, equation 5 this one, and again lambda equal to h by p. Okay, this one, lambda equal to h by p, equation 6. Okay, you got equation 6. Equation 5 this one, lambda equal to h by p. Equation 4, here 3, 2, and this equation 1. You got equation up to 6. Perfect. So what happened if I want to calculate the particle is moving at that time? I want to calculate the particle is moving, having the energy, right? Then what happens? When body or particle have in motion at that time, it possesses some energy. That energy is called as kinetic energy. So what is kinetic energy? The kinetic energy is nothing but the energy possessed by a body due to its motion. When it is in motion, at that time, the kinetic energy is observed or generated due to its motion. Okay, and that energy is, what is that energy? Is k equal to half mv square. What is it? K equal to half mv square. That's it. Okay, half mv square. So here written. Okay, so kinetic energy ek, k indicates kinetic energy, right? ek is what? Kinetic energy, which is equal to half mv square. Okay, then what happen? Half mv square, right? How I will write this? Multiply and divided by m on RHS, right? Right hand side, we have multiply and divide. Multiply, divide with mass m. Okay, then what happen? Half m square divided by m, right? So m is what here? M is momentum, right? So m square v square is what? P square. That one is momentum square divided by twice of mass of the moving particle. So p square equal to what? Energy, kinetic energy of the particle, right? Okay, kinetic energy of the particle, or which we can say photon, right? Okay, then what happened? P square equal to kinetic energy into twice of mass of the photon or particle which is possesses the kinetic energy. Okay, then instead of taking this, okay, what I have taken here, I have considered here p square equal to twice of mass into kinetic energy ek. So if I cancel this square and p, right, momentum of photon, which is equal to square root of twice of f into kinetic energy. Okay, then how I will write the equation 6? What is the equation 6? Here equation 6 is here. So what is lambda? Lambda equal to what? H by P. As you know, equation 6, this one, H by P. So how I will write here? P equal to square root of twice of M into here H as it is. Okay, square root of, you write instead of this P, you can write this square root of twice of mass of photon or moving particle into kinetic energy. Okay, EK. That's it. Okay. Here this one. You got the equation 7. Perfect. Lambda equal to H by square root of twice of mass of photon moving particle into kinetic energy EK. This one. You got this equation. Perfect. And after that, if material particle are in thermal equilibrium associated with temperature T, right? So then what happen if that material particle or photon have in thermal equilibrium, have a particular temperature, then I have a particular temperature T, then how I will express it? I will express kinetic energy of that moving particle or photon Ek equal to 3 by T into Kt. What is K? K is Boltzmann constant, as you know, right? K is what? Boltzmann constant, which is equal to 1.38 into 10 raised to minus 23 joule per Kelvin, right? Then I have calculated this equation. Which equation? Above 7. If the photon or material particle are in thermal equilibrium at particular temperature T, then how I will write the kinetic energy of that particular uh, material particle or photon? Ek equal to 3 by 2 into Kt. So put this value in above equation 7, this Ek. Okay, kinetic energy. So lambda equal to, again I will write here, lambda equal to, okay, lambda equal to H divided by square root of, what is it? Twice of mass, right? And what is the value of kinetic energy? Ek, 3 by 2 into Kt, as it is, right? 3 by 2 into Boltzmann constant into temperature T. That's it. Okay. So lambda equal to, how I will express it? Planck's constant H divided by square root of thrice m k into T. Okay. Make this equation yet. Okay. So this one is the de Broglie's equation in terms of energy. You can calculate energy, right? Okay. In terms of energy, you can we have derived that energy equal to h nu by, here equations 1, 2, 3, 4, 5, 6, right? Here energy we have calculated, that energy is here, we have kinetic energy, right? Okay, P equal to this one. Here we have kinetic energy calculated, right? Okay, and for temperature we have 3 by 2 kT, right? Kinetic energy of the material particle or photon, okay, which is in motion. Put this value in equation 7 and you have to got the lambda equal to h by square root of 3m into Boltzmann constant into temperature in Kelvin. Okay, that's it. If any student have the any questions, they can ask. Okay. This one is the de Broglie's wavelength in terms of energy and temperature. This carries 10 marks. Derive an expression of de Broglie wavelength in terms of energy and temperature. Okay, that's it. And another uh, article we have uh, take that one is d Broglie phase velocity and particle velocity. This carries 10 marks, I think so. Okay. So for uh, de Broglie phase velocity and particle velocity, uh, relation between them. Okay. So for de Broglie phase velocity, a wave is disturbance from equilibrium condition that travels or propagate with time from the region of space to another. That's it. And the original displacement gives rise to an elastic force in the material adjacent to it. Then the particle is displaced, and then the next, and so on. Therefore, every particle begins its vibrations little later than its preceder. Okay. Therefore, there is progressive change of phase from one particle to the next. And that phase relationship of these particles is known as or called as wave, and the velocity with which planes of constant phase propagates through the medium is called as wave velocity or phase velocity. Therefore, the velocity of advancement of monochromatic wave through medium is called as wave velocity. Very simple definition. What is wave velocity? The velocity of advancement of monochromatic wave. The velocity of advancement of monochromatic waves through a medium is called wave velocity. If we are to consider the equation of plane progressive wave, that is equal to what? Y equal to a sine omega t minus kx. A sine. Okay, we cannot write here due to space problem. Okay, but you know that y equal to plane progressive wave equation, as you know in 12th class, right? Sound waves. Y equal to a sine omega t minus kx. So here y equal to a sine inside the bracket omega t minus kx. Here what is the, here omega angular frequency, which is equal to phase difference 2 pi divided by periodic time t. Okay, that is the time interval to complete the wave. Okay, here. Okay, like this. Okay, omega equal to 2 pi divided by t, which is equal to 2 pi nu. The angular frequency, omega is what? Angular frequency equal to 2 pi divided by t, which is equal to 2 pi into nu. Okay, angular frequency. And k is what? Propagation constant. Omega is angular frequency. Here this one. Omega is angular frequency. And k is what? K is propagation constant, at which rate the wave is propagating in the medium. That one is propagation constant. K equal to 2 pi divided by lambda. So in this case, what is the lambda? The successive distance between, yes, crest to crest and trough to trough, right? Okay, this one is the lambda. Okay, as you know, this one is the lambda, the successive distance between crest or trough, right? This one. Okay. So you can consider any. That one is the wavelength. As you know, you are the second year students. Sorry, third year students. You know very well all those things. Not necessary to explain in detail. So for plane progressive wave, y equal to a sine inside the bracket omega t minus kx. So omega is what? Angular frequency. Omega equal to 2 pi divided by t, which is equal to 2 pi into nu. Okay. And for propagation constant k equal to 2 pi divided by wavelength. As you know, this one is the wavelength. Okay. Successive distance between crest or successive distance between trough. Okay. When wave is formed. Okay, so the term omega t minus k is represent the phase of wave motion. What is it? The phase of wave motion. Okay, at which rate it proceeds in the medium. It propagates in the medium. Therefore, hence, the constant phase can be written as what I will write the constant phase. If I want to write the constant of phase, then how I will express omega t minus kx. This one is the equation, which is equal to constant. I will write the constant for this case. Okay. So differentiate this constant phase omega t minus k dx divided by dt, which is equal to 0. And after differentiating it, right, dx by dt, which is equal to omega by k equal to u. Now this equation 1. After differentiating it, u equal to what? Dx by dt, right? Dx displacement at which rate it is proceeding in the medium, right? Proceeding in the medium, right? Okay. So that one is called as phase velocity or wave velocity. Okay. Then for phase velocity, it is the ratio of angular frequency omega to the propagation constant k. Okay. This one is the wavelength, as you know, lambda, right? Okay. What is it? So if I write the phase velocity, then how I will therefore it is the ratio of angular frequency omega and propagation constant k. What is this phase velocity? The ratio of w to k, the ratio of w, that is the angular frequency to the propagation constant. Okay, what is it? Yes, phase velocity. Phase velocity is nothing but the ratio of what? Yeah, 10 minutes left, please. Angular frequency divided by propagation constant. That's it. And the phase velocity nu equal to nu by lambda. U by lambda. Make equation second. Nu and here are the nu and lambda are the frequency and wavelength of the wave. Right? Equation second, this one. Right? Okay. So what is the equation second? Nu equal to u equal to nu into lambda. Phase velocity equal to frequency into wavelength. Okay. And equation 1 is what? Equation 1 is dx divided by dt, which is equal to angular frequency divided by propagation constant, which is equal to, oh, what is it? Oh, what is remaining? Okay. Here, phase velocity, right? U. So W by K, angular frequency divided by propagation constant, that one is the phase velocity, U equal to frequency, right, divided by propagation constant, sorry, wavelength. Okay, nu into wavelength, that's it. So after that, if E is the energy, if E is the energy, yeah, what happened with this one? Yeah. Yeah, this one pen, there is problem for pen. Okay, right now resolve it problem. If E is the energy of the wave, then how I will express it? How I will express it? Then its frequency nu equal to, how I will write, equal to h nu, energy equal to Planck's constant into frequency of the photon or moving particle, material particle. Okay. Then nu equal to what? E by h. Make this equation 3. Okay. Okay. Then if de Broglie wavelength of material particle, then de Broglie wavelength of material particle lambda equal to what? H by P. H by P is what? H by m was momentum, right? So lambda equal to, make this equation 4. Okay. Lambda equal to h by mv. Therefore, from equation 2, where is equation 2? this one, phase velocity, this equation, phase velocity equal to frequency into wavelength. Okay, so you can write here, you can write here equation, which one, phase velocity equal to frequency into wavelength, which is equal to, write equation 3 E by h into h by momentum, equation 4. Okay, this one, and we got the phase velocity, right? What is the phase velocity? Yes, the phase velocity u equal to energy divided by momentum of the material particle or photon, which we can say, right? mv. But we know that Einstein mass energy relation E equal to mc square, right? Make this equation 5. Okay, and after that, using Einstein famous equation, Einstein mass energy equation, E equal to mc square, this equation. Okay, E equal to mc square. After that, hence we know for the phase velocity, U equal to E by here, E by mv momentum, right? Minus here this one, right? mc square divided by momentum, right? Okay, which is equal to this cancel m, this cancel m, right? Here only left the what? Velocity square divided by this v. Okay, what happened? Make this equation as 6. This equation 6. Okay, and here v is the velocity of particle, right? And c is greater than phase velocity nu, right? Velocity. So this is the uh, phase velocity. Okay, what is it? Phase velocity. I think there is 4 minutes are left. Okay, I once I repeat it, for de Broglie phase velocity and particle velocity. Okay, already I have explained. Once I repeat this, okay, after that group velocity we can see tomorrow. Okay, only phase velocity is sufficient right now. So for what is the phase velocity? As you know that, once I repeat from starting, the velocity of advancement of monochromatic wave through a medium is called wave velocity. That's it. So as you know that in 12th class you will learn that progressive wave. The equation is what for that progressive wave? Y equal to a sine inside the bracket omega t minus kx. That's it. So what is the omega t? What is the angular frequency? Omega is angular frequency and k is what? Propagation constant. So angular frequency equal to 2 pi divided by t, which is equal to 2 pi nu, right? And lambda equal to what? 2 pi divided by lambda, propagation constant. Okay. So the omega t minus kx, which is equal to constant, if I differentiate this with t, time t, then what happened? Here omega t minus k dx by dt equal to 0. If dx by dt, right, which is equal to angular frequency divided by propagation constant, which is which is which is nothing but the u, that is phase velocity. Sorry, yeah, there is u, phase velocity, right? What is it? U is what? Phase velocity. So u equal to what? Dx by dt here. Here u equal to what? Dx by dt. Okay. Oh, I think I have again forget that point where it is pen. Okay. So again that phase velocity u equal to dx by dt. Okay, that is called the phase velocity. And once I u equal to frequency into wavelength, okay, u equal to the phase velocity, frequency into wavelength, that is the wave velocity. Make it as equation 2. After that, equation 3, if you are to take the equal to energy, if E is the energy of wave, right? If E is the energy of wave, then E equal to Planck's constant into nu. Okay, or frequency equal to frequency of photon, right? E divided by H Planck's constant. If de Broglie wavelength of the material particle lambda equal to H by m phi, that is m is nothing but the p, make this equation 4. And from equation 2, the phase velocity of the associated de Broglie wave can be u equal to wave velocity, sorry, phase velocity equal to frequency into wavelength, angular, right? Is the what? Frequency into wavelength. Okay, for this case, right? Which is equal to E by H into H by moment of mass into P. So nu equal to E by mv. And again, if I compare this using famous equation, Einstein famous equation, E equal to mc square, then what happen? U equal to, is the what? Phase velocity equal to E by mv, which is equal to mc square divided by m, again this one, right? E by mv, right? Here mc square divided by mv, here m cancel, here m cancel, here, okay, left here c square divided by phi, this one. Okay, that's it, and make that equation 6. And v is the velocity of a particle in this case. And I think